Yes. Hi everyone. How are you doing? Uh, Welcome to this another video. Uh, we have this kind of question related to differential equation. Uh, we are asked to find the solution of this differential equation. As you see, we have this condition. That's why we have to get equation with no constant. So let us try to answer this question where we have this equation as second order differential equation. We are going to look this side. As this side we have 0, means that this differential equation is homogeneous. Remember, homogeneous differential equation has this form. Let me put letter A here. First derivative plus let me use B here, A here, plus CY, which is, if we have 0 here, this differential equation will be what we call homogeneous differential equation. So we have 0 here. This is going to allow us, we are going to make this a quadratic equation with let me use, you can use any letter you want, letter M, letter B, letter lambda, any letter you want. I'm going to write M for this second derivative square plus 8 first derivative M plus 25, which is equal to 0. As you see, we have a quadratic equation. We need to solve, but I want you to know this. As a homogeneous differential equation, when we have the value of M, when determinant is equal to 0, we have M1 which is equal to M2. Homogeneous solution will be here we have we'll have C1 plus C2x e power mx. But if determinant is greater than 0, means that M1 is different to M2 but are real values. So homogeneous solution will be C1 e power M1x plus C2 e power M2x. If determinant is less than 0, means that we have negative here. In this case, we have M1 and M2 as a complex roots will be alpha plus or negative beta I. So your homogeneous solution will be e power alpha x c1 cosine of beta x plus c2 sine beta x. So we have three cases. Let us try to solve this and see which case we are going to use here. We have m square plus 8m plus 25, which is 0. Let us find determinant. So we have this quadratic m square plus m plus 25, which is 0. Determinant will be, this is a, b, c. Determinant, remember, is equal to b square minus 4 times a times c. So determinant here will be 8 square negative 4 times a is 1 times c, which is 25. So this will be 64 minus 4 times 25, which is 100. So this will be negative 36. So as determinant is less than 0, we are going to solve the value of m in complex form. Remember, this negative will be equal to negative I square, sorry. So this will be equal to 36 I square. Negative 1, remember I square is equal to negative 1. So this negative this I square stands for this negative 1. So let us find m1 and m2. Remember, take minus b, which is minus 8 plus or negative square root of determinant, which is 36 I square over 2 times a, which is 2 times 1. So m1 will be negative 8 plus, this will be 6i over 2. By dividing these two, here we have negative 4 and here plus 3i. m2 will be negative 8. We are going to use negative here, negative. This is 6i over 2. This will be negative 4, negative 3i. As you see, m2 is a conjugate of m1. So here we have the same numbers where alpha is negative 4 and beta, which is 3. Remember, in this case, homogeneous solution will be equal to e power alpha. Alpha is this real part and beta is imaginary part. X times c1 cosine of beta x plus C2 sine beta x. So homogeneous solution will be e power, remember alpha is negative 4x bracket C1 cosine, remember beta is 3x plus C2 sine 3x. Let us continue. Good. So this is the homogeneous solution in this form. But remember, you have these conditions. When x is 0, y is 2. And when x is 0, first derivative is 1. So, as you see, we need to find the first derivative here. For this function y, let us differentiate both sides. Here we have first derivative, which is equal to, this is a product. We need to differentiate this times this plus this derivative of this times this one. So that's why we have this one derivative e power negative 4x derivative times C1 cosine of 3x plus C2 sine 3x plus this one derivative of this e power negative 4x C1 cosine of 3x plus C2 sine of 3x derivative. Derivative of this will be negative 4. We are going to differentiate this here. E power negative 4x C1 cosine of 3x plus C2 sine of 3x plus e power negative 4x. Okay? We are going to differentiate this. The derivative of cosine 3x, take this and make derivative here. This will be 3c1, but remember the derivative of cosine is negative. So this will be negative 3c1 sine 3x here, plus the derivative of cosine will be, we are going to differentiate this, 3c2 cosine 3x. This is the derivative, but we can factorize e power negative 4x, but it is not necessary. So let us replace this value. We have this function and this derivative. When y is 2, from this here, when y is 2, sorry, when x is 0, y is 2, we are going to replace the value of y here, and the value of x, this will be e power negative 4 times 0 c1 cosine of 3 times 0 plus c2 sine of 3 times 0 So this will be 2, which is this e power 0 will be 1. Not necessary to write 1. This is 1. Okay, here we have cosine 0, which is 1. Cosine 0, this is 1. We have C1 plus sine 0, it's 0. C2 times 0, which is 0. So C1 is 2. Let us come back on this first derivative and replace the value. When x is 0, first derivative is 1. Again, we have first derivative, which is 1, which is equal to negative 4 e power negative 4 times 0 times C1 cosine of 3 times 0 plus C2 sine 3 times 0 plus e power negative 4 times 0 bracket negative 3 C1 sine 3 times 0 plus 3 C2 cosine 3 times 0. So this will give us 1, which is equal to, and again this is 0 e power 0, which is 1, and we remain with negative 4. This cosine 0 will be 1. That's why we have C1 here, plus 0, because sine of 0 is 0, plus e power negative 4 times 0. This is 0, means that we have 1 here.